Okay, hello. I'm going to make a quick video just showing the parametric CNC model that I've been working on here in Fusion 360, which is based on the wooden plate or the birch ply plate CNC machine that I've been making, which I've nicknamed CNC Mountain. I've just more or less finished the individual plates, and I've done this while learning how to use Fusion 360. My machine is based on an open source series by OpenBuilds and takes inspiration from other similar machines, including the OpenBuild Korea lead screw CNC machine, the C-Beam Sphinx, the Ultibot and the R7, and also the videos of Martin Balfour. I'll link to all of those things in the description. But I wanted to make my own variation to satisfy some of the requirements that I might have with a CNC machine, and also to add my own design implementations and engineer things into the machine that I think might be useful. The first thing were openings on the plates which would hold a proximity sensor. Now, while working on this particular machine, I've been very conscious to try and set up some parameters so I can make some alterations to the machine which can then allow me to adapt some of the features. So for example, if I wanted to change the opening diameter of the proximity sensor because for whatever reason I've found a new sensor that works better, maybe it's cheaper, and I want to incorporate it into the design, I can track down onto this list of parameters and I can change an expression, and then the opening will change its diameter. So I think I call this simply just proximity sensor. If I change that, that should change as well, and the hole just changed, and the surrounding area, which I've described as the proximity mount, stays the same. If I want to change that to 15 for whatever reason, for aesthetic reasons, that changes as well, but the spacing of the holes and everything else stays more or less in the same place. And if I go to another part of the machine, you can see big chunky mounting plate with the hole. I do undo change parameter, and back down. In fact, I think I changed both of them there. Yeah, that's fine, 12.5. I've also added some openings so that I can actually access the grub screw at the back of some of the plates, which tensions or pulls the nut block onto the threaded rod, the Acme threaded rod, so it reduces the play. The other alteration I did from my prototype CNC machine was to change from large V-wheels to mini ones, for example on the Y plates. When I initially modelled the plates with two types of wheels, I noticed they didn't line up. The larger wheel has a slightly different thickness to it, and it wasn't sitting entirely aligned in the centre of the aluminum extrusion, and even if I added or subtracted a shim on the various wheels, this didn't seem to solve the problem. If I show you this side of the machine here and I get rid of that plate, you can see a similar thing here. So these wheels line up well there, but the next wheel is pushing into the extrusion. I modelled this machine in Fusion with metric spacers, but the one I actually built used imperial. So there was 6.35 mil, and I think that actually had touched onto the opposite side, although of course I was using birch ply plates, so there may have also been other factors involved in the spacing problems. What I've subsequently done in preparation of cutting out some test plates for this new design is actually buy a sheet of 0.2mm PTFE and a hollow punch set with a centering point to actually make my own PTFE washers, which I can use to space out the wheels a little bit more accurately and place them in between these two washers here until the wheels line up a little bit better and they're all making contact the way they should be. Designing this machine by the parameters have meant that I can adapt things very quickly. I can go down and change the spindle plate thickness, which are these things here, although I'm going to leave them at 15 because I think that's a practical size. I've got the stepper hole spacing here, which are the holes that the spaces, the longer spaces, go between the plate and the stepper motor, and then bolt the motor in place, and then the hole for the lead screw is centered between those four. So depending on the size of the stepper motors, I could in theory increase the size of the stepper motors and then quickly adapt the plate dimensions. I've got the spindle diameter, so if I happen to get a smaller spindle, if I get a 60mm one, just press 60, and then it becomes smaller. I think that might be a mistake there. Oops. Okay, so that's something I've got to work on. So I've adapted that, but these ones here haven't updated because I haven't set that dimension. If I go to this, right click and edit profile sketch, should be able to do this. So D, click, and this will be spindle, diameter. See what happens when I do this. Bugger. I can lock these. Fix. Do that again. Center to that. That to there. Okay, don't. What's going on in there? It's 80. And then we want to divide that by 2. The radius. Okay, that looks correct. So I stop the sketch. Okay, that looks okay. You can see I've ever so slightly extended that curvature into the opening so it actually clamps down. Obviously I haven't tested it out yet, so it might need to be a bit more or less. If I go to modify, change parameters, and spindle diameter, and I change it back to 60 because I want to use a smaller spindle, boom, it changes. Obviously it's not necessarily in the best position for that size of a sort of spindle, so I'll probably have to relate that to the overall shape. I don't know if there's something I can actually do. Right click, edit profile sketch, we can delete that, that to that. That's a bit of an odd one, 22.3. Essentially this is how I've been doing it. I write some parameters, I include them into the body or the component that I'm designing, and then I make a change and see what happens. Yeah, so that's doing what it should be doing. So now I can adjust the opening of this particular part and it can accommodate different type of spindles. I've also made sure that I line up the openings with the plates, so this is the Z-axis here. The only thing I haven't quite worked out how to do is to line up the center of the hole on one plate to the edge of a profile of another plate. So if I go back to the parameters again, and I look for the plate thickness, and say we're making It's really thin, like 3mm, because we're using stainless steel. 1, 2, 3. Go computer. Don't break. Spinning wheel of doom. You can see the plates. Got some warning messages. We see the plates the hole hasn't adjusted for that. I can't quite figure out how to do that. Also got the bearing holes, so I can again adjust the type of bearing, the depth that it goes into the plate, and also the opening here for the lead screw. So if I decide I want to try and make a slightly more robust machine, I can get a thicker lead screw and then adapt the bearing hole on all the plates. Yeah, essentially that's it. I haven't done any detail on this machine. I've not added screws or brackets or anything that I didn't have to. You can see I've got wheels on this side because I needed to identify the spacing, but once I got those right, I didn't bother adding wheels on this side here. You know, this is purely just to illustrate the design principle and make sure things actually line up and appear to do what I'd want them to do. And it's all joined more or less correctly as far as I can tell, so I can grab onto different plates and move things around as if it was actually a real CNC machine. Okay, I just realized something else. This corner here, if I was cutting out with a 6mm CNC cutting bit, I would have a curved edge in this corner which would affect how this part of the machine joined together. What I could do is start a new sketch on this plate and cut circles into the inside edges, or create a fillet on the outside edge of the adjoining piece, adding a 3mm radius curve. I had to change some of the constraints on the sketches to make this work, and also select new points to join the pieces within the model, but in the end the spindle bracket looks like this now. So you can see the shapes follow the same kind of curvature on either side, and I've tried to add a radius into the design wherever you have an inside corner, because that's what's going to be left behind when it's cut out using a router cutting bit. So the plates should look like how they will come out. The other thing I forgot to mention is I can actually change the dimensions of the CNC machine itself. So if I want to make it wider, I can put the width down that I want, and then the machine redesigns. And then obviously I can take the measurements off the machine to get a rough idea of how big certain parts would be. When I was building the original machine, I did have some problems with the machine screws because they do come in specific sizes, and with some of the parts of the machine, for example the Y plates and the mini V wheels which go into the C-beam, if the machine screws are too long they will scratch onto the aluminium. So it's not as simple as it looks, but you know, there's a lot of information in this model that I can extract before going into a new build, and I think the nice thing about this sort of design and this approach to modeling a idea out is that this is essentially a blueprint which isn't stuck down on paper. So I think what I'm going to do now is export these plates and make them available first to my patrons who have been supporting me since I've started this CNC channel, and I'll leave it with them for a few weeks so they get a head start with building the CNC Mountain, which is what I'm calling it. And then after that time I will make these files available on the Open Builds platform, which is where I've been sharing some of the videos of the build process. This is an open source machine, so please don't write down in the comment, you should patent that. This isn't how it works. This is about working collectively, and I wouldn't have been able to do half the amount that I've done if it wasn't for the information available on Open Builds and on YouTube, and the generous people who share their creativity and time. So thanks again to them, thanks again to my patrons for supporting me, and for any of you random stragglers who've turned up and managed to watch this. I actually fell asleep while editing this video because I found my own voice so boring.